Hello everyone, welcome back to Calculus 3. In this video I am going to talk about the dot product. So far you have studied two operations with vectors, vector addition and multiplications by a scalar. The results of each operation is also a vector. In this video you will study a third vector operation, the dot product. Definition of the dot product. First, let me discuss in 2D system. Suppose you have u vector. This is u1, u2. We can write this one u1i plus u2j, and v vector v1, v2. We can write this one v1i plus v2j. Then dot product of u and v can be defined u1 u2 dot v1 v2. What we do, u1 multiplied by v1, which is u1 v1, plus u2 multiplied by v2, which is u2 v2. So this is the dot product for the u and v in two-dimensional space. Then how about three-dimensional space? Here u is similar, but we have z, u1, u2, u3. This u1i plus u2j plus u3k. V vector v1, v2, v3. This is equal v1i plus v2j plus v3k. So dot product of these two, u dot v equal u1, u2, u3 dot v1, v2, v3. So here we multiply u1, v1, that is u1, v1. Then we multiply u2, v2, u2, v2. Then last one u3, v3. Here we multiply these two. This is the dot product of u and v in 3D system. u1 is a scalar, v1 is a scalar, therefore u1 times v1 is a scalar. Similarly, u2 times v2 is a scalar, u3 times v3 is a scalar. Therefore, summation of scalars is the scalar. The result of the dot product is a scalar. Let me explain an example. U vector, I say 3, -1, 2. And v vector -4, 0, 2. Then what is the dot product of u and v? U dot v equal 3, -1, 2 dot -4, 0, 2. So what we do, we multiply 3 and -4. 3, -4 plus -1, 0 plus 2 times 2. So this is -8. Another example, I write down u equal 3i minus 5j plus 2k, and v equal 7i plus j minus 2k. So what is the u dot v? So here I write down 3i minus 5j plus 2k and here 7i plus j minus 2k. So what we do, we multiply ith components together, j together, and k together. So then we can write 3 times 7 plus negative 5 times 1 plus 2 times negative 2. So this is 12. Then let me talk about some properties of the dot product. Suppose there are three vectors u. You can write down u, u1, u2, u3, v, v1, v2, v3, and w, w1, w2, w3, and also we use c be a scalar. Then first property, u dot v should be the same of v dot u. Second one, u dot v plus w equal u dot v plus u dot w. Third one, the scalar c, then u dot v equal cu dot v or u dot cv. Zero vector multiplied by v, any vector, then what is the answer? It is a 0 or 0 vector. It is a 0, just a scalar. Why? We know this is the dot product. Dot product always it is a scalar. Then the last one, v dot v equal power 2. So v dot v equal, what is this? It is the notation of the length of v. So length of v and power of that, second power of that. So you can prove this, but let me explain an example. So example, I say u equal 3 minus 1 comma 2. I use v equal negative 4, 0, 2, and w equal negative 1, sorry 1, negative 1, negative 2. So let me explain first one, u dot v. So you know u3 negative 1, 2 dot negative 4, 0, 2. So this equal 3 times negative 4 plus negative 1 times 0 plus 2 times 2. This equal negative 8. So let me try v dot u. So that is negative 4, 0, 2 dot 3, negative 1, 2. So this is negative 4 times 3 plus 0 times negative 1 plus 2 times 2. This is also negative 8. So now you see first one is true for this example. So yes, you can prove using general vectors like u equal u1, u2, u3, and v equal v1, v2, v3, so on. So let me go with second one, u dot v plus w. So then u is 3 minus 1, 2. Then what is the dot? U plus v plus w. You know addition of the vectors. So first v plus w, negative 4 plus 1 is negative 3. So next one, so 0, negative 1 is negative 1. The last one, 2, negative 2, 2 plus negative 2 equals 0. Then get the dot product of this. So then 3 times 3 negative 9, 3 times negative 3 negative 9, and negative 1 negative 1 positive 1, and 2 times 0 is 0. Therefore this is negative 8. Okay, now let me consider the right side. I use u dot v plus u dot w. Okay, let me check u 3 minus 1 2 dot v negative 4 0 2, then plus u dot v vector u 3 negative 1 2, and vector w dot 1 negative 1 negative 2. So this equal, let me find the dot product first. U dot v, that is 3 times negative 4 plus negative 1 times 0 plus 2 times 2, and I use this bracket here plus, and I use here 3 times 1 plus negative 1 times negative 1 plus 2 times negative 2. So then here negative 12 and 4, then negative 8 plus 3 4 0. Therefore this is also negative 8. Now you know for this example u dot v plus w equal u dot v plus u dot w. Now let me consider the last one, u dot u. What is the u dot u? So u is 3 negative 1 2 dot 3 negative 1 2. So this is 3 to power 2 plus negative 1 to power 2 plus 2 to power 2. 3 to power 2 negative 1 to power 2 plus 2 to power 2. I can write down this and this, the same thing, right? I got the square root and then get the second power. So what is this inside? That is the length of u. Therefore we can write down length of u is this, and then we have second power of that. So that is the last property I explained before. Before I go to next explanation, let me explain law of cosines triangle ABC. Then we know length of BC is simple A, length of AB is simple C, and this is simple B. Then cosine rule is A squared equal B squared plus C squared minus 2BC cosine A. How do we apply this to the vector? Let me draw this. Now I use vectors, and this is v vector, and this is u vector, and this is theta angle. Okay, so then we don't know this vector. So what is the vector A then? How do we find the vector A in terms of u and v? You see how vector addition works. So vector addition is start from something and it become then terminal point, then this become initial point to the next and go to this, then this is the terminal point. So this is the first initial point, this is the last terminal point or starting point and stop point. So this is the direction of these two vectors. Then resultant vector or summation of A, I say A plus B should be this, A plus B. So you know how the vector addition works. So then how about this A here? How do we find the vector A? Yes, let me show you. Vector V start here in this direction and then A go to this direction. Therefore, V vector plus A vector equal, then this one start from here, stop here. Therefore, this equal U vector. From this, we can have A vector equal U minus V. Therefore, I can write this instead of vector A, I write down this here U minus V vector. Go back to the cosine rule, law of cosines. What are the ABC? ABC are the length. Length of AC, length of BC, length of AB. So how do we find the length of this vector? Or this vector? Or this? Yes. This is the A here I use. You see that A, U minus V. So what is the length of this? And second power, we use the second power of the length. So that is U minus V. This is the length, U minus V and double line here, and then second power of the length of U minus V. Then next one, we need vector U according to this, that is the B vector. B is this one. So what is the length here? Vector is V. Therefore, I can write it is the vector V, length of the vector V and second power. And minus, similarly, here C is the number or length of AB. So this vector U is the C here, corresponding vector. So then, what is the length of this? We know that its length is U. Then we need second power. Actually, this must be positive. Then you understand to, I write down U, V, cosine theta. That is the law of cosines for this green triangle. Then consider U minus V. According to the last property I explained, this is the second power. Vector V power 2 equal V dot V. So that is the last property. So then, can we apply this one to this part over here? Yes, we have this one, we have this one. So what I do, I use the, what is the vector here? U minus V. Then dot, again U minus V by itself, right? So then how do we simplify this? So U dot U minus U dot V minus V dot U plus V dot V. I did, I multiplied these two together and these two. Then I multiplied these two and these two. Then U dot U, it is here same, V dot V, this one. So we can write down length of U and power 2, U dot V equal V dot U. That is the first property I explained before. Therefore, we can add these two. It becomes 2 U dot V. Because you know, I explained U dot V equal V dot U. So we can write down here negative U dot V minus V dot U can be written again U dot V. So this is negative 2 U dot V. The last one, V dot V. So this equal V to power 2. U minus V, the length of U minus V second power equal this one. Therefore, we can write U second power minus 2 U dot V plus V second power equal what? Because you see this equation and this one. You see this and this. It means left side of the both are the same. Therefore, right side must be the same, right? It must be equal. Therefore, what I do, I make them equal. So this is the green part, right side. So v to power 2 plus u to power 2 minus 2 u vector and v vector cosine theta. So here actually these two are vectors, right? So then we can cancel out u and this and this and this. Then you can cancel out negative 2, negative 2. Finally, you can have u dot v equal magnitude of u vector and magnitude of v vector cosine theta. Isolate cosine theta. So cosine theta equal u dot v divided by u, magnitude of u and magnitude of v. I just divide each side by magnitude of u and magnitude of v. We can find the theta equal cosine inverse u dot v vectors and magnitude of this. Here theta in between 0 and pi. This is how define an angle between any two vectors. If theta equals 0 or theta equals 5. If theta equals 0 means suppose these are the two vectors u, v. So this is theta. Theta equals 0 means u and v are coincide. So like this. Or theta equal 5 means this is u and 5 means this should be this way. So that is v then. So if so, you know these are parallel. So if theta equals 0 or theta equals 5, vectors are parallel in the same direction. The first one I use here, same direction or opposite direction. Second one. If theta equal 5 over 2. Theta equal 5 over 2 means this is u, this is v. So 5 over 2 is this, 90. That means orthogonal or we call perpendicular. U dot v equal magnitude of u, magnitude of v cosine theta. If theta equal 5 over 2, so I can write magnitude of u, magnitude of v cosine 5 over 2. Then what is the cosine 5 over 2? That is 0. Therefore, if theta equal 5 over 2, or we can say vectors are orthogonal, then vector u dot vector v equals 0. So this is a very important property. U dot v equals 0 if and only if u and v are orthogonal. Example. Find the angle between u 3 negative 1 2 and v 1 negative 1 negative 2. How do we find the angle? You can always use this equation u dot v equal u v cosine theta. That is the angle we are looking for. Theta equal cosine inverse u dot v over u v magnitude this. So we need to find the u dot v. So u dot v is 3, -1, 2 and dot 1, -1, -2. So what is this? This equal 3, -1, -2. Then you can write 3 times 1 plus -1 times -1 plus 2 times -2. And this equals 0, right? Yes. Okay, dot product is 0. Then theta equal 5 over 2. That means u perpendicular to v, right? Vector. Or you can say u and v are orthogonal. That's the way we use dot product to show that two vectors are orthogonal. Next example, u equal -4, 0, 2 and v equal 2, 0, -1. I show you this one over here. Actually we didn't use that part because we got it is 0. So let me write down here cosine inverse u dot v divided by u v. So we need first to find u dot v. Yes, if we get the u dot v equals 0, then we don't have to do anything. Then that means those two are orthogonal. Therefore theta equal 5 over 2. So let me find this one, u dot v. So -4, 0, 2 dot 2, 0, -1. I know now you understand how to do this. Therefore I write the answer, it is -10. Then we need to find the magnitude of u vector. So how do we find the magnitude of two vectors? U vector, -4 to power 2 plus 0 to power 2 plus 4 to power 2 square root. This is square root 20. Similarly, you can find the v, that is square root of 5. Now we can find the theta equal cosine inverse u dot v equal -10 and this is square root 20 and square root of 5. So you see that this is cosine inverse -1. Therefore you can say theta equal, what is the cosine inverse -1? That is the 5. This is not the end of the section but end of the video. I will explain the rest of this section in my next video.